So we rebranded TM1 to Planning Analytics probably about 10 years ago, but we didn't do a very good job. Everyone still calls it TM1 today. But we use the terms TM1 and Planning Analytics interchangeable. It's exactly the same tool. What we did do though is we took the Cognos front end and we made that the new front end to Planning Analytics. So all the kind of dashboarding, visualizations, and all that sort of capability is built directly into the platform, and that's where the name Planning Analytics kind of came from. It's to reflect how we've changed the product over the years.
Sure.
And then what we've done recently is we've taken Watson X, which is our IT division at IBM, and taken a lot of their capabilities and embedded it into the platform where it makes sense. And I've got a couple of slides just to highlight where we're doing that. Yeah, Watson X now is our umbrella IT, like everything that's AI goes into the Watson X division. So we'll look at that today. So look at the AI components that we've added into Planning Analytics and the new look and feel of I guess TM1, and effectively, and you'll be aware of this, but it's it's a tool that Gartner have coined as an FP&A platform, so extended planning analysis, or the new term this year is integrated business planning. So just fancy terms for allowing businesses to budget and forecast across different areas of the business, as you mentioned earlier. So some of the key capabilities of Planning Analytics, fast performance, you'll probably be aware of it. We used it a while back. It's always been one of the fastest performing budget and forecasting engines in the market, and we've done a lot recently as well to improve that. We've added a lot of self-service exploratory analytics, so the ability to go in and slice and dice, and you always be able to do that in the past and then push it into Excel, but now we've got more of a dashboarding capability as well.
Okay.
So you can do it at a web level. Easy to use web-based experience, which we'll have a look at in a few moments. The ability to scale and adapt to organizational changes. So it's not set and forget. It will adapt to your particular needs. If you add more products, you open new divisions, branches, and so forth, it will adapt very easily. Built-in Excel integration, tool called Perspectives. Very much still at our core today. We know finance love Excel, so we've added a new add-in called we've replaced Perspectives. Actually, Perspectives is end of life or end of support this month, but we replaced it with a tool called Planning Analytics for Excel. So it's got all the capabilities of Perspectives, but a whole lot more capabilities as well. But it's very much at the heart of what we do. Flexible deployment options. So we have obviously an on-prem version, and then we also have cloud options available as well, or SaaS options as well. So obviously available in Australia. We're available on IBM Cloud and AWS at the moment in Australia. Highly visual analysis and reporting. Again, we'll see that in a few moments in the demonstration. That's with taking the Cognos technology and using that as the front end. Everything's secure, governed, and compliant. So there's obviously, I don't know if you remember from back in the day, but there's a transaction log, there's an audit log. We can see who changed what, when, and where, and so forth within the platform. Powerful modeling that supports any business requirement as you start, branching budget and forecasting, reporting across multiple lines of business within the organization. They all do it slightly different. So having a tool that can accommodate those different planning styles is going to be critical. And then the last one there is aligning the planning process to corporate strategy. So if it's done correctly, the Planning Analytics should reflect your strategic goals and initiatives and so forth, and align to that. So if it's to increase market share, reduce costs, increase revenue, whatever it may be, the planning process should enable that and reflect that as you go forward. I'm just going to jump across quickly to a couple of the AI components that we've added into Planning Analytics, and it will kind of frame up what we'll demonstrate today as well. But we've put in what we call AI predictive forecasting. So looking at historical trends and seasonality and using that to predict what's going to happen in the future. So rather than just having a zero-based budget, you can take last year's numbers and then use that to generate a plan moving forward. And we'll have a look at that. We using AI is also to for outlier analysis. So rather than the users going, slicing and dicing and reading tables and trying to find any outliers in the data, we can run AI across the top of that and just immediately identify that to the users where their outliers are within their data, and then they can make corrective action if required. Chart insights. So this is where we're bringing in some of the generative AI components into Planning Analytics. So there is a natural human bias interpreting data, and what we're doing with the Gen AI capabilities is taking out that bias and just giving you a natural language explanation of what's going on within your models. Explain cell. So everywhere within TM1, you can right click on the cell and you can trace that calculation. You can see how it's being calculated. So it might be a consolidation or a roll up, and it will show you the children, or it will show you the actual business rules. So if it's sales equals price times units, it will show you the calculation, the price, the units, and so forth. But what we've done is, so Planning Analytics or TM1 loves complex calculations, and sometimes those calculations can look very complex to the users. Yeah. So what we're doing now is using AI to give a more natural language, business-friendly explanation of what's going on using AI. Impact analysis. So this is designed to show you relationships within your data. If I change my price, what will that do to my volume and sales and so forth? And then the last one is Data Explorer. So in the past, the users would have to open up a cube view, and then slice and dice and push it into Excel. What we can do now is use natural language and just go, show me revenue performance for 2025. And it will go and build you a view on the fly rather than you having to go into the back end. So we're trying to make it a bit more easier for the users and lower the barriers of adoption when it comes to Planning Analytics. All right, so let's have a look at some of this in action. But this is the web-based front end called Workspace. So this is based off using our Cognos Analytics capability as the new front end. So this is the landing portal for Workspace. At the top, you get a nice welcome message. You can customize this with your logos up here. New users can play a video and see the capabilities of the platform. And then below there, we have what we call My Applications. So as I mentioned before, Planning Analytics is designed as a FP&A or integrated business planning solution. So a lot of our clients will have 20 or 30 or 40 different applications. This screen here will filter the applications based on the user's profile. So back in the day, in TM1 days, you used to have a whole lot of Excel files on a network share somewhere, and people would have to go and find them and open them up. Here, when they log in, they automatically see the applications that are relevant for their day-to-day job. So if they're in finance, they'll see financial planning. If they're in the corporate team, they'll see corporate planning. If they're in supply chain, they'll see supply chain. Campaign planning, we'll see marketing. Sustainability team will see their applications. So, but this screen will filter the applications based on the user's profile. So what we'll do is jump into a couple of these just to give you a bit of a sense of what the user experience is like. So what we'll start off with is a bottom-up planning example here called guided planning. So we've got a bit of workflow in here, and we're going to use some of our AI capabilities to produce our plan moving forward. So if I launch this quickly. Here we are. So on the left here, we have effectively what we call the navigation pane. So it's got the name of the application, a brief description of what the application is doing, and then we can break up the application into individual tasks and then guide the user through their planning process. So in this case, we've got 3 tasks the user needs to do. So update their revenue, update their CapEx, update their OpEx. Each task may have a different due date, and it will have one or more assets assigned to that particular task. So to update revenue, they need to update an asset called planning. If they jump into CapEx, it'll load in the capital asset, and then they can just start updating. So they're not looking for different sheets to open and so forth. As they click on the task, it will automatically load.
Sure.
If I go back to revenue, once the user has completed their task, they can hit the submission button. Here they can put some rich text or narrative around the submission. So numbers tell half the story, but they can complete that story with, in this case, I've updated my revenue numbers in line with CPI, inflation, certain promotions we're running. We can also upload any supporting documentation, be it an Excel file, PDF, PowerPoint, whatever it may be. And then when I hit submit, depending on how we structured the workflow, it might go to my first line manager or regional manager. That person will get email notification that says Kev's updated his revenue numbers. Please click on this link to approve or reject his submission. So what we'll do is update our revenue numbers. I'll just minimize this pane so we can see the planning asset a bit better. The first tab we land on is all around scorecards and metrics, and the idea of this tab is to give the user a bit of a sense of how the organization is currently performing before they get to the demand planning tab. And what we're going to do is create a demand plan for our revenue numbers. But on our scorecards and metrics, I've got a summarized P&L view. Obviously, the users can drill up and drill down, so I could drill down on total operating expenses and so forth. Across the top, I've got my actuals, my budget, my variance percent, my status, how do my actuals and budgets compare. And on the right, I've got what we call our list filters. So we've got a number of filtering styles depending on the available real estate and the user behavior we're trying to enforce there as well. But here I've got effectively my region dimension. I can look at total company, Eastern region, Central, Western, and so forth, and my widgets will update accordingly. Down at the bottom, we've got some out-of-the-box visualizations. We're about 30 visualizations at the moment. Workspace is on what we call a continuous delivery lifecycle. So there's a new version out every single month. We're adding new visualizations and new front-end capabilities. So users are always up to date from a look and feel perspective. So here we've got what we call, the first one's what we call a network diagram. This is designed to show the user relationships within the data. So this demo is based off an IT manufacturer like Apple. In the middle, I've got their product categories, so tablets, phones, and PCs. And on the outside, I've got the regions that we're selling through, and we're looking at revenue numbers. So the darker the gray line, the more revenue we're selling of that product category through that particular region. Next to that, we've got a bubble chart where I've got my products as bubbles and based on units or volume, and then revenue across the bottom. So I can see what my high volume selling products are, 3G smartphones, but our biggest revenue earners are our 4G smartphones. So lower volume, higher margin, better revenue. Obviously, we can drill in and interact with these visualizations as well and go down to individual SKU levels as well. Next step, we've got what we call Mapbox integration. So if we can represent the data, let me expand it a little bit so you can see better. If we can represent the data geographically, it just helps the users to understand a bit better what's going on. We can go down to an address level. So one of our retail customers got 961 stores across Australia. So we've got a map of Australia. They can see how each of the states are performing. And then they go down to a city level and see how each of the stores are performing in relation to each other. In this case, we're at a country level, but we can see Germany and France are doing quite well. Spain and Portugal need a bit more assistance and so forth. All right, so what we're going to do on the demand planning tab, this is where we can start updating our demand plan. We've got a number of different filtering styles on this one as well. So this one here, this what we call our drop-down filter. So here I can click on my product dimension. I can look at total products. I can look at a product category called phones, or go all the way down to an individual SKU level if I want to as well. So this is what we call our drop-down filter. Across the top, we've got our horizontal slider bar as a filter. So I can either look at total company or a state level, or I can go down to a Sydney level and start updating my demand plan using the slider bar. So different filtering styles. And then what we're going to do now is we're going to update our demand plan for Sydney down to 3 different channels and down to 12 months. And we're at a total product level. So I've got about 100 SKUs sitting under this level, and we're going to create a demand plan at that level. The other thing we can do in here as well is I can create a what we call a sandbox. So it's a personalized what-if scenario on top of in this case, the demand plan. So to create a sandbox, I can come up here. And I can just go and create sandbox. Let's give it a name. Let's give it Kev. I don't know what version we're on yet. Version, let's do 55. And then so now I'm in my own personal version, so I can play around with the numbers and they're only visible to myself. So I can go in here and I can do things like breakback. So I could change the whole of October by 10%. So I could just come into the cell here, type in increase by 10%. And that's going to go and update 3 channels down to 100 SKUs. So about 300 cells in less than a second. So this one, what we're looking at the moment is our SaaS offering, but on-prem and SaaS is exactly the same version of the software, same capability. So you can do either or. But this one here is currently in our being hosted out of our US data center, so our demo environments are actually hosted out of the US. So you can see even from a wide area network perspective, the performance is really, really good.
Speed is really good, yeah.
Yeah, a lot faster than we used to have with the Excel integration. So we can do things like, so I changed everything there proportionally by 10%, but we can say that I don't want to increase stores. I want to just increase online and wholesale. So I can do things like hold. So I can right click on there and go and hold. And I can come to the highest level and go, this time I'll make it a whole number. Let's make it 8K. That increase will only get applied to online and wholesale. So it's not an all or nothing thing. You can cherry pick where you want to apply those, what we call wholesale changes. But say I want to change everything, but just deselect certain, in this case, channels. We've added a lot of shortcut keys as well to help the users update their plans as well. So for example, if I want to make March for wholesale 2,500 for the remainder of the year, I can just do 2,500 to the right, and then that will just update 10 months down to 100 cells, so around about 1,000 cells in less than a second. The other thing we notice is that people get a calculator out or a spreadsheet to work out the value to put back into TM1. So what we allow users to do now is use formulas to update the cells. So for example, for February, I want to sell 200 units for every day in February, so 200 times 28. The result of that formula will get written back to that cell. So you can use formulas. Or I can get a bit more sophisticated and go, I want to start at 2,100 and I want to grow by 10% per month. So it will start at 21 and then effectively do a straight line with a 10% month-on-month increase. We can apply different profiles like 4-5 weeks for expenses and so forth for construction companies like S-curves, but we can apply different profiles to the data. The other thing we can do as well is I've got 3 years of historical data, so 22, 23, and 24. I can use that data to predict what my demand plan will look like in 2025. So what the user can do is they can highlight which rows they want to run a predictive forecast on. So in this case, I'm going to run it for all 3 channels. So I'll highlight all 3. If I come to the top right and click on this forecast icon, the user gets presented with 2 predictive forecasting methods. One's called univariate, one's called multivariate. We'll look at univariate first, and then we'll look at multivariate in a couple of minutes. So if I click on univariate, it will load the univariate forecast wizard on the right. I tell it when I want to forecast from and to. So I want to forecast from January 25 to December 25. And then on the advanced tab, I can deselect certain historical time periods. So I might want to exclude COVID years from my historical data. I can set up acceptable ranges. So this is, as I mentioned, this is for an IT manufacturer. They have certain constraints. They can only got certain raw materials and how much they can actually manufacture. So there's no point running a predictive algorithm and it's going to forecast more than we can actually physically manufacture. We can set those constraints in here, a maximum and a minimum level as well, so that the engine won't go above or below that limit. When I run preview at the bottom, what the system is going to do is going to run 9 exponential smoothing algorithms across each of the different channels. It's going to identify the seasonality and trend in each channel and picks the most appropriate algorithm out of the 9 that best fits that seasonality and trend. So at the moment on the screen, I've got stores, but if I hit the drop down, I'll have the 3 that I selected. But for stores, the fixed line here are my actuals. The dashed line here is my predicted demand. And then the shaded area is our confidence range, or how confident is the system in its prediction. So it's not magic fairy dust. It's not always going to give you 100% accurate results all the time. It's got a lot to do with the quality of the data and the granularity of the data as well. So it's very important that we inform the users. Can they trust these numbers, or should they use their own business insights in forecasting these numbers? On the statistical detail tab, this tab is designed to give the user a bit more information of how these numbers are being generated, to help with the trustworthiness and explainability of how these numbers are being generated. So we got the predictive accuracy, we got the model that was selected, so exponential smoothing. The trend that was detected was additive. The seasonality was additive. So the specific model it selected was the additive Holt-Winters method. And then on the left here, I'll have all the measures and parameters that were used to generate that demand plan. The user can hover over each one of these. It's got a detailed explanation. And then what we've done recently on the right here is we're running a Gen AI across that information to give a more business-friendly explanation of what these measures and parameters are doing, but it's giving a more natural language explanation here on the right, and what it's and how it's generating these numbers. The other thing the system will do as well, if I jump into online, it will detect any outliers in your data as well. So you can see here for online in December, it's highlighted an outlier here, indicated by this red square. And what we can get the system to do is correct that outlier. So I can come over here and adjust that outlier. And what it's going to do is effectively smooth it out. It's going to move it from that blue dot down to that green dot. Mm-hmm. And that's the pattern expected to see over time. So now you can see the confidence range is really narrow, because we've smoothed out that outlier. It may be we may want to leave it in there and put that in and use that as part of our forecasting, but we can use the system to kind of smooth that out for us to give us a far more accurate forecast. I'll quickly show you wholesale, just to show you why we've got this confidence band as well. You'll see here it's a really wide confidence band. Effectively, the system can't detect any seasonality or trend in the historical data. So effectively, it's just doing a straight line from the last actual month. And so hence why the confidence band or range is really, really wide. So the user should trust these numbers with a bit of pinch of salt, because effectively it's just doing a straight line from the last actual month. So what we could do now is I can come out of this, and I can go forecast, and it will take those that demand plan, those preview numbers, and it's going to seed that into my plan. Give it a couple of seconds, and it'll launch it into there. So the idea behind that is to improve forecast accuracy and the speed at which the users can generate their demand plans, or any plans. So it could be expenses or whatever it may be. So once the numbers are being pushed into here, they can then augment these numbers. So for example, the system is predicting we're going to sell 1,779 units in January for wholesale, but I expect to sell 2,000. We're running a promotion in that month, so I can go in here and overwrite that number and then put 2K in there. So I can tweak the numbers as I need to as things change over time and so forth. So that's univariate. I'll quickly show you multivariate. I've got a different example for multivariate, which is this guy here. So univariate is effectively looking at one variant, which is just time. So, and it's looking at seasonality and trend over time. But there may be other factors that will influence, in this case, your demand.
Right, external impacts.
Yes. Yeah. So here I've got things like, how many business days are in a month, consumer spending, or how much disposable income do our customers have, which will be at an all-time low in Australia at the moment, although it's improving with interest rates coming down. Inflation rates, unemployment, we can bring in weather data, precipitation, temperature, and so forth, may influence the demand. So we can bring that information in here, and I can feed that into the prediction. So what I'll do is I'll run a multivariate on this product here called 5G 32 gigabyte. All that sort of stuff we can bring in. Effectively, what it's doing is just looking for correlations in the data, right? So if there is a Taylor Swift constants in Brisbane, then obviously all the hotel accommodation goes up and stuff like
Yeah.
that. So it's just
Yeah.
looking for that so we can bring that information in. And it's funny, some of those things do make a massive difference.
Absolutely, they do. Yes.
Yeah. So let me quickly run I'll show you how the multivariate is slightly different from a univariate. You still tell it when you want to forecast from and to, but down here at the bottom right, we can start adding those different variables in. So at the moment, I'm looking at consumer spending and I'm looking at unemployment, but I can go in there and look at other factors that we've loaded in. So things like business days and so forth. So effectively loading those factors into a cube, into Planning Analytics, and then we can go and reference it in here. So what I'll do is I'll run a preview and I'll show you what does slightly different in here as well. So on the statistical detail tab is a new section on the right here called relative contribution, and it will tell the user out of the factors or variables they've selected, which ones are actually contributing to the predictive strength. So we can see here consumer spending, or how much disposable income our customers have, has a low contribution to the predictive strength, less than 4.9%, while unemployment has a strong contribution or correlation to the predictive strength at 95.10. So effectively what we're clicking on is what we would call as an essentials item. So if someone's employed and they've got money, they go to purchase products. If they're unemployed and got no money, then they're obviously not going to purchase products. It doesn't matter how much disposable income our customers have. It doesn't influence the demand for this particular product. So it's not a luxury item like a Louis Vuitton bag. It's more like an essential item like milk, bread, butter, and so forth. So not only will the system generate a demand plan, but it will tell the users which factors are actually contributing to the predictive strength. So one might be at Taylor Swift conference, and that might have a strong contribution, but it will tell, based on the historical data, it'll be able to tell the users which ones are the ones that are actually generating a more accurate demand plan, and then the user can swap that out for a different one if they wish to, and so forth. All right, so that's multivariate. I'll show you. So we call that, it's more what we call traditional AI, and that's been around for quite a while. But where we're going now with the product is putting things like AI assistants into the platform, generative AI components. So let me jump over to the screen here. I got a different example. So here I've just got a standard looking dashboard in Planning Analytics. Why is that? Let me just refresh this. This is taking a bit too longer. I have to log back in. There we go. Okay. So this is what a typical dashboard looks like in Planning Analytics. So yes, leveraging a lot of the Cognos Analytics capabilities in here. But what we've added at the top right here is the Planning Analytics Assistant. So this AI assistant is based off our Watson X assistant technology, but we've trained it up on Planning Analytics TM1. So it understands what a database is, a cube, a hierarchy, a dimension, a business rule. So there's zero code involved in this. You just point it at your data and off you go. So when you load it up, it's got some commonly asked questions, but the most common one is the help down here. So this is very similar to Workspace. It's on the same continuous delivery lifecycle. So there's a new version out every single month, and we're adding more and more capabilities to this assistant. So the goal of the assistant initially was to lower the barriers of adoption. So we realized people don't use Planning Analytics every day, every hour and so forth. So they forget what they can do within the platform. They forget what the menus do, the icons and so forth. So what we wanted to do is deliver a more natural language, intuitive experience with the platform. So on the right here, we got a list of features or commands that we can use within the tool. So I can open a cube, I can explore, I can slice and dice, I can drill up, drill down, hide, keep members. I can create a sandbox. So earlier I created a sandbox and called it Kev version 55 or what it was, but I had to click on the spade icon, then go create sandbox and then type in the name. Here in the chat I can just go create sandbox, give it a name, and off I go. I don't have to remember there's a spade icon to do that. I can create charts on the fly. I can create calculations. So these are view calculations. So I can work out the average of the columns or sum up the rows or whatever I want to do. There's still got the TM1 business rule engine behind the scenes to do your sophisticated calculations, but these are more view-based calculations that you can do from here. And then copy, redo, and so forth all works in here as well. But I'll show you some stuff we can do in here. So you can click on any widget and then you can go, what I want to do as a user, I want to swap my rows and columns around. I want to slice and dice. Now there's an icon that allows you to do that, or you could use the mouse, but as a novice user, I forget that. So I just can come in here, I can type in the word swap or flip, and that will swap my rows and columns around. Or I can undo that and it'll go back to the way it was. I could change it from a table into a visualization. So I could just say switch to pie chart, and that will convert that table into a pie chart. Previously, the user would have to go up, find the visualization menu, select pie chart, configure it, and so forth. It will automatically just go and do that for you. Or what I can do now is get some insights in this visualization. So I could go and say, show me insights. Oops, go away. Show me insights. And what this is going to do is generate me a natural language explanation of what is going on in this visualization. So it'll give me a bit of an introduction, a bit of an analysis, and it'll give me a bit of a conclusion at the bottom here. I can copy this text, put it back into the dashboard, into a PDF or Word document. If I go to key points, I find this tab a bit more, gives you a bit more insights, but it'll give you the key statistics, any trends that it detects, any notable observations that we want to bring to the user's attention, and any insights that we're gaining from this data. And then we can obviously copy this and use it wherever we want. So we're trying to take the natural human bias interpreting data within visualizations. We can just run this and generate these insights.
Mm-hmm.
From a table point of view, we can go and identify outliers. I can go in here and go show me outliers. And that's going to go and scan my income statement cube and highlight any outliers that we have. So all the rows in that cube have come in here. So gross revenue, sales, and so forth. But for gross revenue, it's identified a outlier here in March. Gives a bit of a synopsis down at the bottom. So how many outliers it detects, what were the extreme values, any patterns it detected, the implications of these outliers, what they may be. And then we can go through each of these different lines and it will identify any outliers that we have and so forth. Rather than the user trying to read the table and figure it out for themselves, we can then call it out for the user. The explain rules, and it's going into the actual calculation, and it can see where your units have changed and your prices change, and telling you a story around that. You can ask it a question: what's driving my biggest variance from a consolidated view? And it goes down and it says these products in these regions are causing you the biggest variances and stuff like that.
Great.
That's where we're going to be going with it. So with that, let me show you. So if I go analyze this will show me the impact analysis of this cube. This is an income statement cube, so the impacts and direct and indirect relationships are going to be quite obvious. But in here, we can click on like gross margin, and it will tell me what's influencing or what's impacting my gross margin in the table on the right here. So gross revenue at 37%, net profit at 29%, cost of sales, net profit after allocations, and so forth. So it's showing me, relationships within my data. If I had sales and price in units, it would show me that sales is impacted based on, volume and price and so forth, and give you a bit of a synopsis down here at the bottom as well, and showing you these relationships. And then what we can do from here is take all this information and then generate a report for the user. So I can come in here and I can go and do an expiration analysis. And effectively, it's going to take all those anomaly detection or outliers, all the impacts, and then generate a PDF report with an exec summary and so forth. Give it a couple of seconds. Here we go. So it'll create me a PDF. maybe, there we go. With an exec summary, the relationships and dependencies between my data. So it's basically ran it across my income statement at the moment. Analysis overview, recommendations, but it'll go and show me all the impact analysis, the relationships within my data, what's influencing gross margin. And so calling out everything that, we've been running from the front end, but just creating a PDF that the user can then go and start, having a look at what's going on in this particular cube, which is the income statement cube. Let me jump back to here and reset this dashboard. So I don't know if you remember, but in TM1, you could right click on any cell and then trace it, and it will tell you how it's been calculated. So here I've highlighted variance for gross revenue. I can click on trace cell and it will tell me how that cell's been calculated. So that negative 34 million has been calculated based on a variance calculation. It's looking at actuals at 73 million and version 1 at 108. So that's why I'm getting my negative 34 million. Now, if I expand the rule out, here, most people think variance, sometimes can be a very simple calculation, which could be just actual minus budget. But in this case, this calculation is very complex in that the customer wanted to have a dynamic variance calculation based on where they were within the calendar dimension. So they wanted the first 9 months to be actual minus budget and the last 9 months being actual minus forecast. And then for usually revenue numbers are stored naturally as a negative number in your source system and in Planning Analytics. But from a variance point of view, you want to switch those signs around. So it's looking across your account dimension to see if if it's an expense account, it uses the natural sign. If it's a revenue account, it switches the sign and so forth. And this is effectively what this rule is doing. But for a normal business user, it's very complicated and very difficult for them to understand. Even for a tier 1 developer, it will take them a few minutes to figure out what's going on. So what we're doing now is if I do the same thing, but do explain AI, it will give me the same information. But over here, it's going to give me a more of a business-friendly, natural language explanation of what's going on. It'll tell the user what the purpose of the TM1 rule is, and then go through and then break it up into its individual parts and it's looking at an attribute called switch sign on our account dimension to swap the sign. And then the second part of the calculation is looking at a cube called compare against cube, where it's looking at where you are within the calendar to see what version it needs to do the comparison against and so forth. And then gives you a bit of a logical flow and then a summary. And then we can actually add this explanation as a cell comment. So the user can just look at the cell comment and so forth. What we're going to be doing soon with this as well is there is a TM1 transaction log that shows what the old and the new values are and who changed it and when they changed it. We're going to be bringing that in here as well. So not only will we be able to tell the user how has it been calculated, but we can tell the user how has it changed over time as well. So all these capabilities have always been in TM1, but it's been very much an admin sort of function. But they've got a lot of value for the end user if it's presented in the right way. So we'll be able to help the users understand how things have changed and be calculated and so forth. And then let me just show you actually we go to this one here. This is the Data Explorer. Actually, sorry, I've got too many servers here, but usually this will just default to your current server. But in here, I can go in here. So instead of the user going to the cube, opening a cube view, slicing and dicing, and then pushing it into the dashboard, which they can still do, they can come in here and just ask it a question and go, show me revenue performance. Let's do I've got old data in here for 2015. Actually, sorry, 2015. And what it'll do is it'll go scan my cubes and build me a view that's best going to help me answer these questions. So on the right here, it will build me a cube. It's actually looking at my revenue cube is the recommended view, but another cube that I may want to use is the income statement cube because it found revenue in there. And then down here at the bottom, it's going to give me an explanation of why it built the view the way it has. So what dimensions and measures is it brought in to give me the information that I'm looking for. Or I can go and run the same thing on my income statement, and it will generate me a similar view, but on the income statement. So rather than having the user go into the back end and try and find that out, you can see in here, it's automatically brought up the year 2015. It's brought up my gross revenue, and it's showing me by quarter. And then down below here, it'll explain why it's built it this way. And then what I can do, if I was in edit mode, I could just go insert this view into my dashboard, and I can start slicing and dicing. Actually, if I just do that again and let me just go into edit mode and do the same thing. Oh, what's going on with my mouse? So what I can do is go and insert that into my dashboard, and then I can use to turn this into a bar chart. I could go switch to bar chart, and that will go and convert that, hopefully, there we go, into a bar chart and so forth. So that's where we are at the moment with the AI journey. So then the next evolution is, so it understands, what rules are doing. Now we're going to be getting it to write the rules for us as well, or giving you a bit of a code assist in writing those rules. And because it understands, it can now interpret the rules, we're going to get it to be able to write the rules. Our goal is, in the past, TM1 Planning Analytics has been very reliant on developers, and we're trying to shift away from that reliance on developers and allowing power users or analysts to do a lot more within the platform with not having too much reliance on developers. Is where our goal is. Everything you know before is still there. So this is effectively the Server Explorer that you would have clicked in Excel, and then it would show you. Oh, why is my server so? Actually, why is it so slow today? But yeah, so applications are where all your TM1 web sheets are sitting. So I don't know if you remember using TM1 Web back in the day.
Yes.
All that's available. So I can bring in an Excel TM1 web sheet and put it in here as well. So they all sit under those folders. And then obviously under my cubes, I've got all my, dimensions and views and everything sitting underneath that you're probably used to from the TM1 days. So behind the scenes, it's still TM1 under the covers. And then you can see where I've got the little plus symbol. What we've done is run an AI analyzer across these two cubes, the income statement and the revenue cube. So when I ask it a question, it's actually only querying these two cubes. So generally clients will have like 50 or 60 different cubes, but from a reporting point of view, or what they want the user to run AI across, might be a subset of those cubes. So you can actually tell the system which cubes you want to have the ability to run AI across.
Fantastic.
Cool. 2 minutes over.